Hello everyone, here we meet again. Myself Gokla Vashni and I'm working as an assistant professor in the Department of Food Technology in SNS College of Technology. So today we shall learn about the thermal processing equipments used in the food industries, and we can also see about the fouling of evaporators and heat exchangers in the food industries. So let us get into the topic. So first of all, what is fouling? The fouling is an accumulation of unwanted materials on the surface, especially in the industrial settings. It is the general term given to the process in which a variety of species present in the water or wastewater can give increase in the resistance of a membrane by the adsorption or deposition onto the membrane surface on every complete pore blocking. So these flocculants can include inorganic salt, organic matter, biological substance, that is microorganisms, and colloidal particles. The mechanism of the fouling are complex and can involve the physical, chemical, and biological process. The consequences of fouling are reduced efficiency, increased energy consumption, and shortened equipment lifespan, making it control essential in many equipments. So first of all, we shall see about the types of fouling. So there are four types of fouling. So first is a scaling, and next is a particulate fouling, biofouling, and corrosion fouling. So first we shall learn about the scaling. So deposition of a materials like calcium carbonate, magnesium sulfate, and other salts on the heat transfer surface is called scaling. So this is particularly common in systems that uses hot water or where water is heated, so causing the material to precipitate out of the solution and form a hard insulating layer. So next is a particulate fouling. So accumulation of a suspended solids and sediments from the fluid onto the surface is called a particulate fouling. So this can include everything from the particles and sand to split and the debris. So this fouling reduces the heat transfer efficiency and increase the pressure drop, hiding the system performance. So next we shall see about the biofueling. So the biofueling is nothing but a build-up of biological materials such as algae, bacteria, fungi, and other microorganisms on the surface. So the growth can be biomicroorganisms, which further attracts more microorganism and organic matter. So it leads to the significant fouling and potential corrosion issues. So next we shall see about the corrosion fouling. So here the it results from the reaction between the material and the process fluids. So it causes the corrosion and deposition of the corrosion products. So this type of fouling can significantly degrade the structural integrity of equipments and reduces its shelf life, that is efficiency, which often leads to the costly repair or the replacement of the whole equipment. So these are the types of fouling. So next we shall see about what causes the fouling. So the fluid properties, the material and the roughness, and also the environmental conditions. So fluid property means we shall say like temperature, velocity, and composition of the liquid, so which can greatly alter the temperature, that is if there is more fouling, it requires the more temperature transfer through the material. So next we shall see about the materials and roughness. The heat exchanger material and the surface condition are crucial in the heat transfer progression, and also when there is a fouling, the material itself to be changed sometimes, or further measurements should be taken. So the roughness surface provide more stiffness for the initial deposition and microorganisms growth. So next is the environmental condition. So the main factor for the biological growth is the pH levels, and although the water hardness plays a significant control levels in many types of fouling. Extreme pH levels on entrance corrosion and scaling process. So high water hardness intoxicating a high concentration of a dissolved material such as calcium and magnesium promotes the formulation of a scale deposited in the heat transfer medium. So next let us see about the impacts of fouling. So how the fouling impact the temperature and also the heat transfer rate of material. So first it reduces the efficiency and also it increases the pressure drop, which in a further process the equipment is downtime, that is we need to change the equipment completely. So first of all, the reduce efficiency. So energy uses increases by up to 10%, resulting in a higher fuel consumption and also increased emission. So next is the increased power drop, pressure drop. So the further it leads to the higher operational cost and also pumping power, as a system must work harder to maintain the given value. Next is the efficient and automatically due to the increased pressure that the equipment fails to work continuously. So it requires the frequent maintenance and also interpretation, leading to the production of loss and also increased labor cost. So next is how can we detect this and monitor this? So first of all, we can use a thermal performance. So efficiency drops are measured to assure fouling severity. So this involves analyzing the heat transfer rate and also comparing them to the baseline value to detect any performance degradation indicates of a fouling buildup. Next is online sensors. So real-time tracking of fouling using the specialized sensors. These sensors continuously monitor the parameters such as pressure drop, temperature and deposit thickness, providing immediate alertness when fouling reaches the official level. Next is a non-thermal destructive testing. Now this is one of the easiest methods. So infrared thermography identify the problem area without the damage and by capturing the thermal images. So these are the techniques for detecting the scaling and fouling of the heat exchangers and evaporators. Next are the what are the mitigation strategies to be followed for to avoid the fouling. So first is a chemical cleaning. So we shall use some certain chemicals which will not corrode the equipment, also which is not harmful for the food items. So these chemicals are used wisely. And next is the anti-fouling coating. So we can coat the materials with the anti-fouling coatings to avoid the coating, so that fouling and scaling can be avoided. Next is a mechanical cleaning. So in employs technique like pigging, that is inserting a device to scrap the pipeline valve can be done. Next is a fluid pre-treatment. So mostly hardness causes the scaling, so we can pre-treat the fluid and then we can further process the fluid for the heat transfer. And next is the emerging solution. So what are the emerging solution can be followed? So first of all, self-cleaning exchanges can be used, and next is the fouling resistant materials can be used for heat exchanging, and also predictive maintenance, regular maintenance can be used, and AI machine cleaning can be AI and machine learning can be practiced in the industries to avoid the fouling and scaling process. So in conclusion, effective fouling management is crucial for economic, operational and environmental reasons. Neglecting fouling leads to the increased energy consumption and higher maintenance cost and reduced equipment lifespan. So for fouling and scaling can cause a major loss to the company and also to the power consumption. So this should be avoided, and also it should be tracked regularly. And thank you. Let us meet in our next lecture.